This is the next video in the chapter on atoms, molecules, and ions. We are not quite ready to talk about multiple atom compounds yet, but this is a good place to introduce it because we've just talked about chemical symbols. So we'll have 5 minutes to talk about chemical formulas. So when we gave the chemical symbol, that was the smallest unit that was represented as single atom. But remember that chemical compounds contain multiple atoms within a molecule. So the smallest unit of a compound, which usually contains multiple elements, is called a molecule. We will be working with these a little bit more later, but molecules have several kinds of elements in them, so they need to have several chemical symbols. And there's different ways of drawing them. So we can represent molecules in several ways. And I'm going to introduce them here because I think it'll be useful for you in the laboratory and in your homework problems to be able to recognize a molecule when you see one. So the usual way that we see molecules represented is as a molecular formula. And the molecular formula is just a list of all the different chemical symbols of each of the elements involved. So we're going to use methane as our example, and methane has 1 carbon connected to 4 hydrogens. So this chemical formula contains a chemical symbol for each element, 1 for carbon, which is C, and 1 for hydrogen, which is an H. And it contains these subscripts, and the subscripts indicate the number of atoms in a molecule. So every molecule of methane is going to have 4 hydrogens, and every molecule of methane is going to have 1 carbon. Even though there isn't a number listed here, that invisible unlisted number is a 1. So if the number of atoms in a molecule is 1, we don't write it. Often omitted. Okay, so this is how we'll usually see it, and the advantage of representing the molecule as a molecular formula is it is easy to type in on a computer and it takes up the least amount of space, but it also gives the least amount of information. So there are other ways of drawing a molecule that give us more information about it. One of those is called the structural formula, which we'll be using in a few weeks. And the structural formula tells us about the structure. So it connects each of the atoms to the other atoms using little lines in between them. And these lines represent the bonds that hold the atoms together in the molecule. So the bonds show how atoms are connected. So advantages of this model shows the connectivity and more information about the structure. Disadvantages takes up a lot more space than this little condensed molecular formula. We also have versions of the molecule that look more like pictures. So one of the versions of the picture is called the ball and stick model. And it's called that because when you physically build it in real life, you can use spherical balls and little sticks to put it together. So that one would look more like this. There would be a sphere for each atom. And it has different kinds of bonds drawn in to indicate the 3-dimensional geometry. So it gives accurate geometry, tells us more about the arrangement in space. And we will worry about what these different kinds of lines are that I have just drawn in a little bit later when we get to geometry. All you need to know right now is that when the types of lines start to change, this means that you're giving more information about the geometry rather than the structural formula, which just suggests that this entire molecule is flat on the paper. The final way that we draw pictures of molecules to give us more information is called a space-filling model. And as the name suggests, it shows how much space each of the atoms takes up. So it is usually not drawn, it's usually drawn by a computer, but I'll give it my best shot here. It looks something like this, like that. So it's a representation of the size of each of the atoms and how they fit together. So accurate atomic sizes. So again, pros and cons. These bottom three types of models all take up a lot more space to draw than the molecular formula, especially as we start to get to bigger and bigger sized molecules, but they give us information about the connectivity, the geometry, and the atomic sizes that can be valuable. So you can choose to use each of these, any of these types of models, depending on what information you're trying to look at. Okay, so while we're talking about molecules, let's just throw this in here and talk about what different types of molecular formulas look like. So a molecule can contain multiple elements, or it can contain multiple atoms of the same element. And there are only some elements that do this, so you'll have to watch out for them as we give examples during the class. So if there are multiple atoms of the same element, for example, if there's multiple hydrogens in one molecule, we aren't just going to write H, 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 because that takes up a lot of space. We are going to wait for the camera to come back into focus again. That's a little bit better. And then we'll write the formula. So here's a molecule, the molecule H2, and that means that this one molecule contains two hydrogen atoms that are bonded together. So the structural formula would look like this. Or this also happens for sulfur. You can find molecules of 8 sulfurs that are all connected together, and they look kind of silly. The sulfurs are connected together in an octagon sort of a shape. Nothing is stranger than real life. 1, 2, 3, 4, 5, 6, 7, 8. There we go. Semi-okay looking octagon. Or you might find oxygen. Oxygen also occurs as a diatomic with 2 atoms of the same element connected. And I just want to take this opportunity to clarify that this H2 is not to be confused with similar looking structural information like 2H, which is 2 individual hydrogen atoms that are not connected, or 2H2, which is 2 H2 molecules that each have 2 H's in them. You see how students can easily get confused here. So let's go over it one more time. So H2, that is a hydrogen molecule. And the 2 is a subscript indicating that there are 2 hydrogen atoms inside of one molecule. This down here, these are 2 hydrogen atoms because the 2 is out here as a coefficient rather than a subscript, meaning that there are 2 units that look like this. So these are not connected. And this one includes both. We know the molecule looks like an H2 where the 2 H's are bonded together, and the 2 in the front tells us that they are bonded, that there are 2 of them, 2 molecules of H2. So watch out for that notation. The subscripts and the big coefficient numbers tend to get a little bit confusing. So watch out for the number of atoms in a molecule versus the number of molecules.